Today on Engineering Newswire, brought to you by PD&D TV, we're building a Bionic Dragonfly, fishing with the FrankenDrone, and testing mustard gas on Petman. To help test the durability of hazmat suits, Boston Dynamics has unveiled its Petman, or Protection Ensemble Test Mannequin robot, which can perform rigorous tests like running, jumping, crouching, and crawling. Wow! That actually looks like a real person strapped to a treadmill doing things against its will. Fascinating in a somewhat horrifying way. Although tethered by a power cable, Petman's balance is more dynamic and natural than other bipeds, and it outdoes other humanoid robots with its skin, which has sensors embedded into it to help detect leaks in the suit. That's not all. The robot also artificially perspires to help maintain a microclimate inside the clothing. Boston Dynamics says that Petman has been delivered to a testing facility where it is undergoing validation experiments. Soon, the robot will be installed inside of an exposure chamber where it will be tested against the likes of sarin and mustard gas. Talk about your 50 shades of Terminator! And now, Ben Heck! Heck yeah!
Yeah! There's a new Kickstarter out there hoping to float your boat, albeit a very small one. Inventor Larry Friese is hoping to manufacture a remote-controlled tube-shaped vessel called the FrankenDrone USV for Unmanned Surface Vehicle. It's mostly hollow, so you can put cameras or other things inside of it, and you can bolt things onto the exterior frame as well. Like all boats, the majority of the cost is the motor, which drives a propeller like an airboat. Submerged propellers can become tangled, which is enough of a pain on a large boat, let alone one you're remote controlling way over there. Larry's Kickstarter still has a ways to go. Might we suggest some reward add-ons such as, crap, I lost my hat retriever, or a gizmo to get fishing lines out of trees? That's what I'd like on a boat.
Murata Boy, the bike-riding robot,
Murata Boy,
showcased his innovative technologies at Chicago's Museum of Science and Industry for National Robotics Week. A mere 50 centimeters tall, this bike-pedaling biped is packed with high-performance electronic components, including ultrasonic, shock, and gyro sensors, Bluetooth modules, and DC-to-DC converters. The stuff typically found in cell phones, cars, televisions, and computers nearly make this little man a real boy. In addition to the hands-on demonstrations and in-depth presentations, Murata Electronics made a donation to the museum's Science Minors program to support STEM education. Science Minors is a youth development program that helps teens learn about science, meet science professionals, and conduct experiments with museum guests while fulfilling service learning hours. That's all and well, but let's get to the heart of the story. The public wants to know about the link between Murata Boy and his cousin, unicycle aficionado Murata Girl.
Murata Girl!
The pair, who are built from similar stock, have been seen traveling the world together of late and have grown suspiciously close. Be careful, MB. Her profile may say she's shy, but I get the sense this 6-kilogram vixen was built to make Murata's little Johnny 5 feel alive.
I feel alive!
The new Bioniccopter from Festo has managed to harness the power of Dragonfly flight characteristics. Just like a real dragonfly, the robot is incredibly light, it can fly in all directions, hover in midair, and glide without beating its wings. In addition to control of the shared flapping frequency and twisting of the individual wings, each of the 4 wings also features an amplitude controller. With a quick tilt of the wings, the direction of the thrust is changed, and the control allows the intensity of the thrust to be regulated. Sensors, actuators, and mechanical components, as well as open and closed loop control systems, are installed in a very tight space, and adapted to one another for a precise system. An ARM microcontroller calculates all of the parameters relating to mechanical adjustment based on input from the onboard inertia, acceleration, and position sensors. Together with pilot input, they then translate these into movement by actuating the servo motors. Utilizing the wireless real-time communication, the Bioniccopter manages to achieve the elegant flight of a dragonfly with the awesomeness of robotics. However complex and impressive the engineering is behind this thing, I just can't help but think about the Dinobots. and the absolute necessity to transform a bipedal metal warrior into a robotic dinosaur.
Nice dino, good dino, sweet dino, won't you step into the nice spaceship for blood? Pretty please, pretty please. Nice dino, good dino, with sugar on top and a cherry and some whipped cream. Nice dino, good dino, sweet dino.
Do you have story ideas? Comment below and we'll cover them in an upcoming episode. For PD&D TV, I'm Megan Zimba, and this has been your Engineering Newswire.